Hello guys, welcome back to another tutorial. Hit the bell icon button so that you don't miss out any tutorial.
Hello everyone and welcome back. In this lesson we're going to start to query the Firestore database. We're going to start by querying a single document. Let's head over here to our courses collection and let's start clicking here on the multiple courses until we find a course that has here, for example, a sub-collection of lessons. Notice that not all courses here have this sub-collection, as this is a schemaless database. The courses that you see on your database will not necessarily be on the same order that we have here, but let's take for example this course, which corresponds to the third course on my list, which is the NGRX in-depth course. Now notice that on your database you are not guaranteed to have this same course in this exact position. It will all depend in the order onto which the data was inserted in Firestore. Also, you will for sure not have the same unique identifier that we see here. Each identifier is auto-generated whenever we are adding a document to the collection, and it's going to be unique to the document. Let's keep this in mind as we build our document query. In order to query the database, we are going to need the Firebase software development kit, which is already installed here in our code repository. So we are ready to use the Firebase SDK and query this particular document. Let's start by taking the configuration that we need to query this particular database, and we are going to grab it here from our init database file. You can also grab this configuration here from the Firebase console. We are going to click here on the cog setting and we are going to scroll down. We're going to click here on the option Add Firebase to your web application, and you can also grab the configuration from here if you need it. Let's now go back here to our code repository and start initializing the Firebase software development kit. In order to make things simple, let's quickly do a query here on this page that you see here, which is the About page. This is a very simple component which is ideal for writing our first query. So let's search for the About component, let's switch into it, and let's start initializing here the Firebase SDK. So the first thing that we're going to need is the configuration object. So let's copy it over here for the moment. We are going to see a better way of managing our configuration in a moment. Now that we have our database configuration, let's import here the Firebase SDK. We are going to write the following: import star as Firebase from the Firebase/app package. So now we have here a reference to the Firebase SDK. In this example, we're going to be needing the Firestore functionality of the SDK, so let's import that functionality. If we don't add this import, then our queries will simply not work. We are going to import Firebase/Firestore. If you would need other Firebase functionalities, such as for example authentication or storage, you would have to add here different imports. So the Firebase SDK is modular and you are only going to include in your application the parts of the SDK that you need. Let's now pass our configuration to the SDK. We're going to use the Firebase object and we're going to call here the initializeApp method. Here we're going to be passing our configuration object. Now let's grab a reference to the Firestore database so that we can start querying it. We're going to define here a constant that we're going to call db, and we're going to grab here a reference by calling firebase.firestore. And this in principle is everything that you need to query the database. Now, depending on the moment on which you are watching this course, you might need some extra configuration. We're going to define here a settings object and we're going to pass this settings object here to our database. Now, currently we need to add the following setting to the Firestore configuration in order for our queries to work correctly. We're going to add timestamps in snapshots and we're going to set this flag to true. This has to do with the way that Firestore handles dates on the database. This is about to change the data format, so for the moment we need to add here this extra configuration in order to remove a warning from the console. You might not need this part if you are watching this course further in the future when this problem has been solved. In either case, we are now going to get here a DB object that we can use to query Firestore. we are going to query for a document, so we are going to use the doc method. This is going to take a document path, which is a string that we are about to build, and it's going to give us back a document reference. So let's call the doc method and let's build here our path. So going back here to our database console, we are going to see that the path that we need to build starts with courses. Let's switch here to the database and let's see that we want to access this collection. So we are going to pass in here the courses collection, and then the second part of the path is going to be this identifier here. So going back here to our program, the path is going to be courses / and then this identifier that corresponds to the NGRX in-depth course. And this, believe it or not, is the complete query for retrieving a document. So we just have to specify here the unique document path using the unique identifier of the document. Now we are going to call .get here, and this is going to give us back a promise of a document snapshot. Let's see exactly what is a document snapshot. So we get back here a promise. Let's then add here a then clause. And in the then clause, we are going to receive here a document snapshot. Let's log this out to the console so that we see what a snapshot looks like. As we can see, the API of the Firebase SDK is promise-based and not observable-based. We're going to use an observable-based API later in this course when we switch to AngularFire. Right now, let's head over here to the terminal and let's restart our development server. Once the server is up and running, let's refresh our application and let's open here our console and see the value of the snapshots. So as you can see, we have here an object of type document snapshot that has been printed out here in the then clause. And if we inspect it, we're going to see here a couple of fields. We have here an identifier, and if we click into it, we are going to see that it's the exact same identifier that we have here, which ends in 0WB. It shows some Firestore specific metadata, and we are also going to see that we get here a reference to a document. So the snapshot contains metadata, a reference to the data itself, and the identifier of the document. Let's now see how can we access the data itself. Let's see what is available here in our document snapshot object. If we hit Control Space, we are going to see that we have here available multiple methods. We have access here to the ID property. We have here the exists method that is going to return a boolean saying if the document exists or not. So even in the case if our document does not exist because the ID is invalid or the document has been deleted from the database meanwhile, we are always going to get back here a response object, and the exists method would return the value false. We have here the data method, and this is what is going to give us back the data of the object. Let's now reload the application and see the data in the console. So as you can see, this time around we get here not a document reference but a plain JavaScript object, and if we open it, we are going to see that we get here the title of the course and all the remaining properties. So this is the actual data. Notice that by calling data, we no longer have the information about what is the identifier linked to this object. That is available here in the snapshot via the ID property. Notice that we received here, together with the document top level fields, the titles nested map. And we have also received here the full content of the categories array. So going back here to our database, whenever we query a document, we get all its nested maps and arrays together with the document properties. So an array and a map is considered as part of the document, and it's going to be retrieved every time that we read the document. On the other hand, this document here that we chose did not have a nested lessons collection. Let's choose here another course object that has a nested collection and see if the nested collection is also going to be retrieved, just like it was the case here of the titles map. So let's go through the list, and we're going to find here a course document that has here a nested lessons collection. It's the Angular PWA course, so if we select here this ID and we switch back here to our about component and we replace this ID with a new one, we're going to hit Command S, reload the application, and see if the nested lessons collection was also queried. So if we inspect here our data, we're going to see that the nested lessons collection is absent. absent. This is working as expected because in a Firestore database, nested collections are not considered part of the document. So a collection needs to be queried independently if we want to grab some data from it. It is not included whenever we read the document. This allows for some very powerful querying while maintaining our database easy to reason about. So the lessons business entity is naturally nested inside a course. It's always queried in the context of a course. It's always linked in our UI to a course. So it would not make sense to put the lessons entity here in a separate top-level collection. On the other hand, we want to be able to query a list of courses without fetching their lessons each time. So it's really convenient that embedded collections are not included in the document data. With this database design, we can nest our data as much as we want and as much as it makes sense if the entities are tightly coupled, but we also have the flexibility to query only the data that we need. Now that we know how to query individual documents, let's see how can we use the Firebase SDK to query a full collection. Hello everyone and welcome back. In this lesson we're going to talk about the Firestore unique identifiers that we have been using so far. You might be surprised with the format of this unique identifier the first time that you encounter it, especially if you have a SQL database background and you are used to auto-generated identifiers that are actually sequential numbers based on a counter. Notice that there is nothing in the Firestore database that would prevent us from creating our own identifiers. Let's add here, for example, a document to the courses collection, and instead of using here the auto identifier, let's create here our own identifier. Let's call it Firebase-course, so this would be an identifier that is also a string, and then we could populate here some fields for this document. Let's fill in here, for example, the description, and let's type in here some value. If we now click save, we are going to notice that here in our collection we have added here a new entry, and notice that the key is Firebase-course and the fields contain the description field that we have added. Let's now delete this entry that we have added to the collection and let's add it again, but this time around using the Firebase auto identifier. So we're going to click here on add document. This time around, if we click on save, we're going to notice that a Firebase unique identifier has been automatically generated for us. At this point, you probably have several questions about these identifiers, such as, for example, what is this strange looking format that we see? How are these identifiers generated, and what is the advantage of this identifier format when compared to, for example, a sequential counter? So we're going to answer those questions in this lesson. So this is a randomly generated identifier. It's not based on the current timestamp in the case of Cloud Firestore, so we cannot use this field here to sort in any meaningful way our documents. Another property of this identifier is that this string is completely random, so if we generate the same document 2 times, we are going to get 2 completely different identifiers. One of the main advantages of this type of identifier is that it can be generated synchronously by the Firebase SDK on the client side, even if the connection is offline. Even if we don't have any connection to our Firestore database, we can still generate safely unique identifiers on the client side, create new entities on the client side, and then later on, whenever we have our network connection back again, we can send our objects to the Firestore database in order for them to be saved, and we are sure that the unique identifiers that we generated while we were offline are not going to create any sort of collision with other things that were going on in the database while we were disconnected. Another big advantage of this type of unique identifiers is performance. Imagine a scenario where you have multiple concurrent clients that are all generating documents that need to be added to the same collection. Using a sequential counter, only the server really can generate correctly the unique identifier for each of the clients. So this means that the server, while it's adding the documents of a given client, it's also making all the other clients wait because it needs to generate a unique identifier sequentially one at a time. with the unique identifier solution used by Firestore, that problem no longer exists. Each client can generate its own unique identifiers independently without blocking the other clients. The server does not need to generate the unique identifiers. Instead, the client can generate all the unique identifiers that it needs in a safe way. And now that we have a better understanding of how these unique identifiers work, let's learn how to query the courses collection. Before going any further, let's take the moment to delete this document using the Firestore console. And this, in a nutshell, is everything that we need to know about these special Firestore document identifiers. Now that we understand document identifiers, let's now learn how to query a Firestore collection. Hello everyone and welcome back. In the last couple of lessons we have learned how to use the Firebase SDK in order to query a single document. Let's now learn how to query a full collection. We are going to be querying the courses collection. In order to do that, we are going to use the Firebase SDK and we are going to call the collection method. Here we need to pass the path to the collection. This path starts in the root path of our database and we're going to access here the courses collection directly, which is a root top level collection. Then in order to retrieve the values for the collection, we need to use the get method. This is going to return a promise, so we are going to add here a then clause and we are going to receive here in our then clause a list of database snapshots, each snapshot corresponding to one document of the collection. So let's log out here the value of this snaps variable. Let's now see this query in action. We're going to refresh here our application and we're going to open the console. So as you can see in our console, we now get here a query snapshot. We have here a property called documents, which is an array of 11 entries, one per each course. For each of the course, we are going to get a query document snapshot. So if you open here this query document snapshot, you're going to see that you have here an identifier and we also have here the document reference. So if we want to take this list of snapshots and obtain the data, we can do so in the following way. We're going to start by inspecting what are the multiple methods available in the API of this class. So we have here available several methods, such as, for example, empty, which returns a boolean indicating if the collection is empty or not. We can iterate through each collection element using for each. We also have here information about the size of the collection, but the API method that we are interested in is the docs property. So we're going to call it and we're going to receive here a collection of document snapshots. So for each of those snapshots, we are going to map it into the data of the course that we are querying. We are going to receive here in the map method the snapshot of a given course document and we're going to extract from it the data. We can do so by calling snap.data. And we're going to log out to the console these arrays so that we can check if this contains indeed the course data as expected. Let's quickly reload our application. We're going to open here the console and we're going to have a look here at the return result. So as you can see, we have here 11 objects and indeed each of the objects of this mapped collection corresponds to the data of a particular course that we inserted here in our top level courses collection. Notice that we are missing here the identifier of each of the courses and we can obtain it by calling snap.id in each document snapshot. So if we try this out, we are going to see that we receive here indeed a collection of IDs. What we would like to do now is to get objects that contain both the ID and the data. And we would like to define here an array of courses. Let's start by defining here a local variable and we're going to add it a type annotation. We're going to say that this is of type course array. And course is a custom object type that we have already available in our code base. We can find it here inside the model folder and it defines here an ID of type string and a series of properties that correspond to the properties of a particular course. Let's now see how can we generate a complete course object that contains both the ID and the data properties. We're going to head over here to our about component, and we're going to remove here the code of the collection that we were generating, and we're going to assign it here to the courses variable. Now we are going to change here our mapping function. We're going to add it a body using the curly brace syntax, and we're going to have it return an object. This object is going to contain first the identifier property. So this identifier property is going to be obtained by calling snap.id, and next we are going to add here all the data of the course, and we can obtain it by calling the data method on this snapshot. The type that we are returning here is not identified as the course type, so we know that this is the correct type, so we are going to add it here using a cast. And with this we have fixed our compilation error. We can now take here the courses variable, and we're going to log it out to the console. After refreshing the application, we're going to see that indeed we now have here an array of courses. So each of the elements of the array has both the ID and the data properties of a course. Notice that the query results are not sorted in any particular order. We're going to learn how to order our results later in this course. As we can see, the Firebase SDK promise-based API is very simple to use, and we could use it directly to build our applications and pass data to our view layer. However, as we are writing an Angular application, we have a much better way of interacting with the Firestore database.
Thank you for watching. Don't forget to subscribe to the channel. If you like the video, do give us a thumbs up and share it. Also check out amazing discounts and offers on our premium courses in the description below.